intro slide, and I was like, cool, I'm done. I'm ready.
Did you steal these slides from Phil?
No, I've just given this talk like 4 or 5 times. Yeah, I did steal from Phil though.
All right. I think we're live now. All right. So let me get the link. We've got a Q&A question. Type answer. There's the YouTube link. And all right. So somebody do an intro for Matt.
Cool. Yeah. Thanks for joining us here at Merge PHP. Tonight, pretty excited to have my 7.5 out of 10 best friend, Matthew Trask. He's fallen in score mostly because he won't drive 1 extra hour to come see me. He's really close. We'll see. Next month, he'll be down to a 6 out of 10. And yeah, Matt is a senior backend lead for Ovia Health. He knows RESTful APIs like the back of his hand. He also really loves Graph APIs, so make sure to ask him about that. And tonight he's going to tell us about the ABCs and 1, 2, 3s of HTTP. Take it away, Matt.
Cool. Thank you, 4 out of 10, best friend Ben. I appreciate that. Where do I share my screen at? Actually, where do I share my screen at?
The green button.
You could try hitting Alt S.
I just spent like an hour on my bike. Might be a little tired. Anyways, thanks y'all for having me back. I think I spoke at one of the first Merge PHPs back at the start of the pandemic. So it's actually really cool to see this like continue on even as like everything's kind of lifted, because it makes it a lot easier to like see all of my friends in one place without having to leave my house. So it's kind of worked out really cool in a really weird way. So as Ben said, this is a talk about HTTP. It's called the ABCs and 1, 2, 3s of HTTP. Come on, computer, play nice. As Ben said, I'm a backend team lead at a company called Ovia. I also host a few podcasts. One of them is APIs You Won't Hate with someone you might know named Phil Sturgeon, as well as another really good friend of ours, Mike Bifocal. And then also, it's kind of on hiatus because we've run out of topics to talk about, but Ben and I, once in a while, will do a podcast called PHP Town Hall. I also maintain a bunch of things, openapi.tools, phptherightway.com, and Fractal is starting to get back going again after a little bit of nudging from a few different people. So we are in the process of actually making a 1.0 of that library after years of kind of neglect. So be on the lookout for that. If that's something you're interested in, or if you use that library and you have some thoughts, comments, or anything like that about where 1.0 should take us, please feel free to hit up the repositories and leave us a comments. That way we can kind of make sure we do it the best we can. So what are we discussing? We're doing a crash course in understanding REST with a focus on things like concepts, URIs, verbs, status codes, and headers. Before this talk, like REST is one of those things where it's like you either really, really know it or you don't know it. And a lot of people struggle with anything more than just making simple requests over get and post, put, patch, and all that kind of stuff. So a lot of people look at like deeper concepts of REST as like this, like just a whole kind of dumpster fire of effort. Whereas hopefully after this talk, you kind of come through feeling like you're on top of the world, crushing this 11% hill as this dude's doing right here. So just bring it right back real fast. You know, the concepts, the verbs, status codes, headers, things like API contracts and tooling is all things we're going to be touching on. The only thing we're really not going to be talking about is GraphQL, because that is not REST. You can talk about GraphQL later, or we can't. I'm cool either way. But most importantly, I just want to break down the myth that REST is complicated. So some background real fast. And there's a lot of GIFs too, because I really like GIFs and I think they're a great way to communicate. So we will admire my friend R2 here for a second. But so REST, when we think about REST, there's 4 levels of REST as defined by a guy named Dr. Roy Fielding, who wrote a thesis, his doctoral thesis on REST. And he theorized there's 4 different levels of REST. level 0, and of course it's level 0 because we're programmers, so we start in was it base 0? So the swamp of POX, POX name for plain old XML, where you're just sending XML objects back and forth. You don't care about making sure that the URIs are uniform or that they logically have a structure to them. You might be sending a post request, a create request over get with an attribute that says create, and your code knows what to do. You may be posting data instead of using query parameters, so that way then you can fetch data out of a database, things like that. Your next level is resource-based URIs. So instead of having your actions into your URIs, something like /get users or /create users, you're instead just using users as your resource-based URI, doing all of your operations through the headers, and just letting the URI describe what objects are being worked on through your URIs there. Level 2, the next level, like we're getting almost to the top there. We're utilizing the verbs, the HTTP verbs. Things like get and post are the common ones that everyone kind of knows. Put, patch, delete. You may be throwing in an options call here, a head call every so often. But instead of just relying on get or just relying on post, we're now kind of we're looking at the different operations as well, kind of expanding our API's abilities. And finally, the last one is hypermedia controls, using a thing called HADIOS. HADIOS standing for hypermedia as the engine of application state. I think it's a terrible acronym because people see HADIOS and they think it's some sort of super duper complicated thing. Really, all HADIOS is sending links with your API responses. So a lot of people kind of build REST APIs in a REST-ish fashion. What we mean by that is they're using the verbs, you're using status codes, you're using headers, but you're not really taking advantage of the hypermedia aspect of it. And I know I complain about it online. I know other people have complained about it online, but really at the end of the day, if you're handling codes correctly, if you're handling the verbs correctly, if you have nice resource-based URIs, then not every API really needs hypermedia. So realistically, like REST-ish is good enough for 95% of the world's APIs. So if you can get to at least level 2 of the pyramid of greatness, I would consider your API doing pretty good. Only once you start having outside consumers where you don't have the interaction with them day to day, that's when I would say hypermedia becomes incredibly important. So what REST-ish, kind of going back to the beginning, the swamp of POX. So we have JSON here, but we're getting /characters. It's a Star Wars reference, so bear with me if you don't like Star Wars. We're making a get request, but then we're telling the code the action is actually a post. So we need to take this data and create something with it. So we're at level 0 here. I guess it would be called the swamp of Podge, plain old JSON, plain old JavaScript. One that gets a little bit better, we're getting /Star Wars characters. Ideally, Star Wars would be somewhere in the top level domain. Characters would just be the /, but we're at least using the verb correctly now. We're at least getting data back in a way that is workable and extensible. And who knows, maybe this API has Marvel characters and I don't know, Transformers characters. I'm trying to think of like pop culture references that people my age would understand. It might be /elephants. You never know these days. There's some elephant APIs out there. So in that sense, this URI makes sense, but in the grand scheme of it, I would more expect /characters with the top level domain being what is actually being worked on: Star Wars, Marvel, elephants, Transformers, something like that. This one though does kind of irk me when you have a 200 OK and you have an error in the body. As we're going to see, we have plenty of error codes to use that actually describe when your API runs into an error, that you don't have to use 200 OK and an error. If I do see this, I will call somebody out for that kind of thing. So kind of like, what is REST? REST stands for Representational State Transfer. It was theorized, like I said, by Dr. Roy Fielding in 2000. Just as a point of reference, I was still in middle school in 2000, so This is some pretty old technology. But as I like to explain it, it's kind of like the Honda Accord of technology. This thing still works. It's still popular. Anyone, just about anyone, knows how to build and interact with a REST API. It's just like a Honda Accord. Any mechanic knows how to work on a Honda Accord or a Toyota Corolla, something like that. Whereas like GraphQL is like the Tesla. You have to have a specialized person who knows what they're doing. And that's what kind of keeps me coming back to REST all the time. It's like, I don't want to say the word simple because I know that kind of has different meanings to different people, but it is really straightforward to kind of build this up. So he theorized 6 architectural constraints. 5 of them are still pretty important. The 5th one that is italicized there, we'll talk about that in a second. But so the 6 constraints are a client-server architecture. There's a clear separation between where your client is, where your client code is, and where it ends, and where your server-side code starts and ends. And your API, the URIs, is what bridges that gap. Statelessness. Once the request is completed and the response is sent back, outside of any sort of activity logging that we might be doing on our servers just to track activity, we don't really remember requests. We don't really remember the filters that you sent back. We don't really remember any sort of query parameters that you might have sent with the request. We just, after the GET request is done, the server is kind of reset back to its original state, and we keep moving from there. Excuse me. There's also a level of cacheability. GET requests are cached across all the DNS servers. So as long as you can cache responses and take advantage of certain codes, like some of the 300s, one of them is not modified, which we'll talk about here in a second, because your server is caching them and you can not have to query the database every single time, but rely on a cache, adds to the restfulness. Also, a layered system is another one. That's where you might have a proxy that proxies requests back to a number of different servers. Your API doesn't care which server the request is proxy to. It can respond the same way if it's proxy to all 3. Let's just say you have 3 backend servers. The request is going to be handled the exact same way. The 5th one, code on demand. Back in the day, we used to send JavaScript back over the wire to be executed in the browser. Today, I think people, especially security people, would have a fit over that kind of thing. So we don't really care about that one too much. The last one, though, a uniform interface. And that's kind of where we get into links and things like that. So client server architecture allows for independent implementations, things like iOS, Android applications. Those are going to be 2 separate code bases as long as they can interact with the API the same way. We are abiding by constraint number 1, which is a client server architecture. Also allows us to implement for the web, TV OS, if you have an Apple TV and you're doing something, Watch OS, whatever Android watches are called, Car OS is starting to become a thing now. All these independent implementations kind of bound us to the client server architecture. That is constraint number 1. Number 2, server maintains an intrinsic resource state, which means that it just remembers the state that I tell the server to be in. The client maintains the extrinsic state. If you add filters to a report, your client might remember what those filters are. So the next time you come back to that report, it can make the same request back to the server, but the server is not going to remember the request. The client, that is onto the client to deal with. Cacheability, clients and intermediaries can cache responses. Responses must either implicitly or explicitly through HTTP headers define themselves as cacheable or non-cacheable. But by definition, we should have cacheability throughout our REST architecture. Well, like I said, a layered system, the client cannot discern what server it's being directed to. And the server doesn't care where the traffic is going because it should be able to respond to the request in the exact same manner, no matter if it's on server 1, server 2, server 3, so on and so forth. Like I said, code on demand, ability to send code such as JavaScript back to the client to be executed. This one's highly optional, very frowned upon. Back in 2000, this was kind of a cool thing to do. But now that we know there are some malicious people out in the world, we probably don't want to be doing this one. And then a uniform interface, things like resource identification in requests. So if you're making a request to /users and posting to /users, you can tell what resource you're making requests to through the URI or something like that. self-descriptive messages. If you have an API that's being consumed by third parties that are out of your control, you want to make sure that your messaging through links and other types of things are as descriptive as possible. So that way the client has their own ability to fix issues without having to wait for a server engineer to be around to handle things. And then hypermedia is the engine of application state, providing those links as discoverability. So that way your third party knows not only what requests they can make now, but what could the next potential request be after they finish the initial request. So that's a lot. Especially like I could do a whole talk just on hypermedia alone. So give you a quick second here, just kind of catch your breath before we keep going. And we're gonna keep going. So good news is really like of the last 6, most of the problem comes from hypermedia, and it's really kind of super fixable. And we're going to talk about more hypermedia here in a minute. So the concepts, 3, 4-ish big concepts that kind of revolve around HTTP cores, which if this is like an in-person meetup, if I was at like Atlanta PHP, I'd ask for a show of hands who has been in cores hell. And I'm pretty sure every single hand would go up at some point. It's almost like a rite of passage for developers to get stuck in the void that is cores, hypermedia, and then authentication versus authorization, 2 big concepts for REST security. So cores, cross-origin resource sharing. Sharing is caring. Basically, all this means is like if you have a client making a request to a remote server, they're not on the same IP address, they're not in the same network, you're gonna the client is going to check with the server if it's okay to make this kind of request. And so it's a mechanism to determine whether the remote origin is allowed to access assets or data on the server. The concept is this. So when as a client, if I'm going to make a request to a server, my browser real fast is going to do an options request. An options request basically says, Mr. and Mrs. Server, what can I do on this server, and what requirements do you need me to meet in order to make sure I can do whatever it is I need to do? The server is going to say, hey, that's cool. Here's what, you're allowed to make requests from this particular origin, which is the access control allow origin header. So all of our requests need to come from foo.example. We are through the server is also telling us through access control allow methods. You're allowed to make a post request, you're allowed to make a get request, and you're allowed to make an options request. If you try and make a put, patch, or delete, that's a no-no, and we're not gonna allow the request to go forward. We're also the server's also gonna say, I also want you to put an X ping other header on your request, so that way I know that you really are paying attention. There's a really funny story about Van Halen when they used to tour. They used to put a thing in their rider. It says no brown M&Ms. Everyone thought it's kind of weird, but really their stage setup was so heavy that they had very particular measurements, and they knew if they saw brown M&Ms in the bowl of their in their dressing room, the place that they were playing did not read their rider all the way through, and that there's 99% chance that stage is going to be unsafe. That's kind of what we have going on right here. The server saying, I need you to put this one little header. It can be empty, it can be foo bar, it doesn't really matter, but I just want to see this on here so that way I know that you paid attention in class and you were listening. And then you also have 86,400 seconds to make this request. I think that is 7 days. Math is tricky. So our client gets it and says, hey, cool, awesome. So I'm going to make a post from the foo.example. I've put on my xping other header, as well as my content type, another one that the server says needs to be there. I've set the origin of my request to foo.example, so the server really knows, hey, this is legitimate, I promise. And then the server says, hey, good job, way to go, fantastic. Here's your 200 OK with all of your data. So that's the cores handshake in a very kind of condensed way. People get really messed up around these headers, the access control headers, and we'll break those down when we get to the header section. But once you kind of step back from being in pain from looking at cores, it actually does make a lot of sense. It's just when you get into it and you're struggling with it, it becomes one of the worst things in the world that you ever have to deal with. So hypermedia as the engine of application state. better known as links and discoverability. In fact, if I could, I would probably go back to Dr. Fielding in 2000 as a 14-year-old boy and say, please, sir, don't call it hypermedia as the engine of application state, just call it links. And a lot of confusion would be dealt with in that very second. I highly doubt he'd listen to 14-year-old me, as I was only 4 feet 11 at the time, but I really wish we could have done this one differently. But what we're basically doing is basically saying with a request, I might make a request to API users, and that is just going to be a very bare bones response, as you can tell right here. So I have the ID and the name of the characters that I'm making a request for. And that's really all I should be getting back in just a massive kind of get request for just / users. This is kind of like throwing a massive fishing net into the ocean and grabbing as many fish as you can. And then now the links kind of let me dive deeper into the single specific user that I want to look at. So what we're doing here is we're saying, look, here's 2 characters, Luke Skywalker and Anakin Skywalker. Here's their IDs. If you're curious about knowing more about either one of these 2 characters, you have an href in the links, and that can respond to a GET request. And this will kind of give you more information about that one particular character. So what that might look like is, so we get our first initial request and we say, hey, cool, I want to learn more about Anakin. That's great. So now we know to make a request to API users too, where now we actually start getting more detailed information about this one particular character that maybe doesn't fit the initial wide range of characters that would come back with just the / users. So now you see we have things like roles, affiliations, and then also more links that kind of give us a path to finding out more about what this character can and can't do in our API. So we might want to know more about these affiliations, the ones right there. We may want to know more about the roles that he had in the story. If we need to make a put request to update the user information, we also have that ability right here too. So all links are doing, all Helios is doing is giving you a map to the very next step in my API. Think of it as kind of like a treasure map. X is never going to mark the spot, but instead the links are just going to kind of tell you where the next X might be. So authentication. Authentication is one of those ones that there's a lot of different ways in REST you can do. You have things like HTTP basic, username and a password. Probably the least used, probably least secure out of all of them. Definitely not something you really want to use if you're going to have an API that's being consumed by third parties. You might have an API key, a JWT, or anything like that, just a randomly generated string. This one can really only do authentication only, because we're really just checking, are you allowed to use this key to make a request? You can do some stuff on the back end too, but generally API keys are for authentication. OAuth handles authentication and authorization. And what's the difference is authentication proves you say who you are. So if you go to a bar, you're going to get ID'd. The authentication part is showing your ID, and they're checking that the picture and the name, or at least the picture, matches your pretty face. The authorization, they're checking that at least in America, you're 21 years old and you can legally drink. So that's really what the difference between authentication and authorization is. So what's next is the URIs. And this is the entry point to your API. This is the first kind of place anyone's going to interact with your API. If your URIs are kind of off, they don't make sense, it kind of leaves a bad taste in some people's mouth, especially more seasoned API thinkers are very detailed about how they formulate their URIs. So a few best practices, we want it to be resource-based instead of action-based. I don't put create or delete or update or get in my URIs. I refer to the HTTP verb for that. Rather instead, I tell you it's a noun is my preferred way. And it's what are you interacting with? Generally, they're pluralized. It gets a little tricky with person and people, things like that. But generally, it's always because your first request is going to be /users is just a popular one to keep kind of hanging out on. So anytime you go into the users collection to start operating on a various user, you're pulling out that one user from the collection, which is why in my head, users/ID makes sense. And that's why I always keep them pluralized. We hyphenate them instead of underscore just because it's easy to lose track of underscores in the browser URL window. So a hyphen just makes it easier to read. URI should describe relationships. So if you have like we're gonna look at a bank account example here in a second, but the relationship between the main account holder and the accounts that you might be operating on. And then the last one is one I actually did really learn from Phil Sturgeon, which is if you have a public API, rather than relying on your auto-incrementing database ID to build your URIs, use UUIDs because it's going to kind of shield your data set from external users. So especially if you're in a hot startup market and you're really trying to kind of get some funding, get off the ground, you don't want to have your database exposed. So like the competition can run like a quick little script and just keep incrementing the ID all the way up and up and up and see how big your data set is. A UUID kind of hides that and kind of keeps the stuff that you're working on a little bit more secretive, a little bit more confidential. So what does resource-based mean? It means that I can reasonably determine what resource I'm about to consume, manipulate, remove. It also allows you to manage relationships in the collection. So some good URIs, if you look like api.starwars.com/characters, one that's not that great, get_characters. If you're gonna put the get in there, at least hyphenate it, but really try not to put your actions in your URIs. If I wanted to expose this out to the entire world for people to consume, I'd use a UUID. Realistically, like I could just chop off the last 8 characters because this is the most random of the entire string. But if you want to really make it hard for someone to guess what's going on, return the entire UUID. Whereas if, this one right here, so if I know there's 1, there's probably a 2, there's probably a 3, there's probably a 4. It doesn't take much to do a while loop and just infinitely hit your API. That's going to knock your servers over if you're not ready for it. It's also going to expose your data set. These are all things that we kind of want to keep in mind as we're building our APIs out, especially for public consumption. So looking at some resource-based URIs, so we have our fancy pants bank. And so when you log into a bank, there's probably making a request to some API, some COBOL API down in the depths of the dungeon to /accounts. And then when you go into, like, let's say your checking account, you might have /accounts/1. If you're going to open a new account that some banks let you do online, you might just post to the accounts collection because now we're adding another resource to that collection, which is why the pluralization still makes sense right here. If you want to edit anything on that particular account, maybe you have a nickname on the account, which a lot of banks let you do. You can make a post to that one particular account in that collection. Same thing if you want to close that account. Let's say it was just a savings account that you were using to save away to buy a new laptop or something, and you hit your goal and you're good, you're done. You can close that right there. If you want to drill into like even further into, like, let's say if you have like an account where you shared it with somebody, you might be user 1 going into your savings account here, or creating a savings account on your user for that account. Like a lot of people have joint bank accounts these days. So this is where this example kind of fits in as well. So next up, we have the verbs, which is easily like the funnest. Actually, SAS codes is the funnest part, but the verbs are really cool too. So we're like the verbs, the ones that you're going to run into the most: get, post, put, patch, delete, and options. There's also trace and there's also head, but very rarely do you see those out in the wild. So I'm really just going to focus on these 6 right here. So what is get? Everyone's made a get request. It requests a representation of a specific resource. It should not have a request body, although I think some get requests can handle a request body. Ideally, if you're going to do any sort of filtering or anything like that, it should come through the query parameters, or maybe through the headers if you really want to, but no request body. The response will have a body. It is also safe, which means that it's not going to change the state of the server. So if you make a get request, it should not alter any sort of resource on the database. It's also idempotent. I think I said that right, which means you can make the same request over and over and over and over again, and state will not change. And it's cacheable, which is the other kind of constraint of REST. We can take this GET request, we can cache it away either on the server or on the client and handle it appropriately through something like an E tag or last modified header, something like that, to save database queries, database calls, things like that. What does a GET request look like? Pretty standard /API/users. You might have a content type on, you should have a content type on your response that tells you the data structure that, or the content type, the way our data is gonna be formatted. So you might have application JSON is preferred. You might have application XML. You might have text HTML. You might have text CSV. You might have a number of different content types all being negotiated if you have that much demand for various different MIME types. Usually application JSON is the preferred one. We might send back an E tag as well. That goes back to the cacheability, where this is, at least in this instance, it's an MD5 hash of the response. And I send that back with my response. So when you make a request for the same endpoint, you pass the E tag. I compare the two, and if it looks like it's the exact same, if it matches, I just send back a, hey, nothing's been modified, so you're good to go. And I can kind of short circuit the request before it gets to my database layer. And then I might also say, hey, this is good to be cached for an hour. After an hour, you may want to go ahead and invalidate your cache, because I will have invalidated mine and the data may have changed within that time. So go ahead and re-up your request after an hour. Post is sending data to create a resource. The request is going to have a body. The response may have a body. This is one where purists have one answer and the people who are actually doing the work building REST APIs have a different answer. It's not safe if you make a subsequent post request. It will create another resource on the collection. If you make another post request, it'll make another resource on the collection, so on and so forth. And it's not idempotent. So if you keep making the same request, it is going to change the state of the server. Cacheable if freshness headers are provided. So what does that look like? So we have our request body here. A 201 created is the appropriate response code that we'll talk about. And in my opinion, the appropriate response is sending a location header where you know where you can make the next request to get this data from. Some people will go ahead and refresh the entire collection and send it back with this new object. That's totally fine too. However, I like the location and kind of like the clean end to the request. And then I also will post a last modified header and say, this is the last time this request was modified. So that way you kind of know freshness wise where we're standing with this request. So put, this is one of those ones, put and patch people get mixed up all the time. Put is, you can either create or update an entire resource on a server. So the request will have a body. A successful response will not have a body, although you will probably get an error code and an error message if you do make a mistake. It's not safe. However, it is idempotent because the server knows if you're making a put, it will just continually update. So it'll find the record and update the resource rather than creating a brand new one from nothing. So while it's not safe, it will change the state of the server, probably through timestamps and things like that. You can make this request over and over and over in theory, and the state of the server really shouldn't be changing. It's not cacheable though. And this one does have a few different status codes that's accepted, 201 and 204. You could technically get away with a 200 okay as well, but 201 or 202 accepted are the ones I generally defer to. And what this looks like, where you can send back one piece of data or you can send back the entire object. It doesn't, either way, your code should be able to handle it. But with a put request, you're updating the entire object in the resource. So generally I send the entire object back and just let the server handle it from that way. The same thing though, I'll send back a location header. I'll send back the content location header. as well as when it was last modified. So that way we have some idea of when the last action was taken on this object. Patch, not really used as much. A lot of people like put as their update header. It's a partial update on of a resource on a server. So the request will have a body, the response might have a body. It's not safe and it's not idempotent, because if you're gonna only update one little piece, and depends on what you're updating, you may constantly be causing rewrites of the resource. You can also restrict it via headers, and you can also expect either a 200 or a 204 to come back here. So for this one, it kind of builds on a last example. If you watch Star Wars, you know that Wedge went from red to the red leader at some point during the movies. So we want to update his call sign so that way he gets the big old fancy title, because titles are important to some people. So that's why we're only updating the title here versus on the put request, we updated the entire object. Delete is a complete removal of a resource on the server. Technically, that's not true. In most cases, we're going to have a deleted at timestamp, and we're just going to add the timestamp there. And then if you're using a framework, most of the time it knows to ignore database rows with the timestamp not being null in that column. Very rarely do you actually want to do a hard delete of data. But in our sense here, this is removing the resource from the collection. So if we delete something from our characters, that object should not show up in our collections ever again. The request may have a body, although you could also do it through the URI. The response may have a body sometimes, and I like to do this. If I delete a resource, I like to refresh the collection and send it all back to the client just to kind of save an extra request, but you don't have to do that. It's not safe and it's not idempotent because it is going to change the state of the server. And it is cacheable. You could cache the action and the response. That way you don't have someone subsequently making multiple delete requests on the same user over and over and over again. Status code wise, you could expect a 200, a 202, a 204. They're all appropriate. Whereas a 204 is probably the one most associated with a delete request. So this one, I have both the body and I also have it in the URI here. I would default to the URI, but sometimes people want to make sure that we're actually deleting the very right thing. They don't just want to rely on one piece of data. They want to match all the possible attributes of the object, as well as whatever relationships that object may have. So they pass the entire data back and let the code handle it that way. It's a little more expensive, but it's also a little bit safer in terms of if you are actually deleting things from your database. You might get a 204, you might get a 200 with a message that says resource deleted, and then a re-up or refresh of that data. The options request, this is only really for cores, although you can just make option requests if you want to, just for funsies. And all it's really saying is like, what can I do on this server? What am I allowed to do? The request will not have a body. The response will have a body because they'll say, they'll give you some information about the server. It's safe. You can just make an options call over and over and over and over. It's idempotent. Nothing's going to change about the response. And it should be a 204 that comes back to you. So if you make it to a non-cores, you might just get some basic headers, like what's allowed, what is the cache control. You might get something like what the server is, because sometimes people like to kind of give that information back. If you're making a cores request, you might see things like access control request method, access control request headers, telling you what you are allowed to do and what you need to put in your next request in order to satisfy the server's rules for engagement. Whew, all right. So the status codes, quick turn. As Amanda Folsom once said, so I sat in one of her talks. If you know Amanda Folsom, she's super cool. She kind of dropped off the face of the earth there for a second. Status codes are really cool. And they're kind of like, people treat them like Pokemon once they kind of understand that there's more than just 200 okay, 400 bad requests, and 404 not found. But just because they're all out there doesn't mean you have to catch them all to use to finish a Pokemon reference. You want to use the status code that's appropriate. You want to use the status code that makes the most sense. And a lot of times, just a 400 bad request is all that you really need. Other times you might need a 401 or a 403, and that's perfectly fine. But don't work yourself into a frenzy trying to find the perfect status code, just because more than just the 3 that you thought you knew existed. So what they are is their numbers and phrases give quick context for a request and a response. So the 100s, probably the ones that are very rarely seen in the wild. In fact, I don't think I've ever seen a 100, but they're informational. They just kind of tell you there's like the 100 continue, and all that means is your request is processing, but you can keep making a subsequent request to the same endpoint and keep going. 200s, everything worked out as we expected, so good job. 300s, things have moved around a little bit, so we kind of need to tell you where you need to go next. The 400s, that is, it's a client-side error, so if you're making a request to my server and you did something wrong, you're getting a 400 or a 4XX back. Whereas if it's a 500, it's my fault, and I'm probably having a bad day as a server, so you just got to bear with me. Let me reboot, cool off for a minute, and we'll get back out there in a minute. So like I said, they're not Pokemon. You don't have to catch them all. Just use the appropriate ones where you can. Most importantly, do not use the 200 OK with an error body. That's like the biggest thing. So 200 OK, the appropriate verbs to use this on is going to be like a get request, a put request, patch. You could use it on an options, and you could use it on a delete. 201 created, the appropriate verbs to use this on is like a post or a put, because you're creating a new resource in our collection. So we want to acknowledge that something was created. 202 accepted, post, put, patch, and delete. Generally, this is for put and patch. If you're updating a resource, we've accepted your update and we've agreed that this is allowed and we're going to keep on doing it. It may also be like going back to the bank example, you know, some people have caps on how much they can deposit in one day. So you might, let's say you have a $500 cap, you try to deposit a $1,000 check. My API might say, hey, I accept your request, but I have not completely fulfilled it just yet. That's where a 202 accepted is going to be appropriate. 204, no content. It's going to be appropriate on delete most commonly. It's also going to be accepted on a get request if you hit like /users and you just don't have any users. It's not technically 200 OK because there's no content. So the 204 no content kind of makes sense here. 206, a partial content. Thinking mostly if you're downloading a stream of CSVs, I might, if you have 5 million rows you need to download, I might say, here's the first 1,000 with the 206. So that way, you know, you get to come back for the next 1,000 after you've streamed this one down, make the next request for the next 1,000 through query params, filters, things like that. And I will continue responding with 206 partial content until we've gotten to the end of the 5 million rows, and then return a 200 OK or something like that. 301 move permanently. This is big in the SEO world, especially if you're changing domains. You'll probably throw a 301 so that way you know your users know that at some point this domain is going to cease to exist and all traffic needs to be moved over to your new domain. You probably want to return something like a location header or content location header, giving them a map to the next location as well. 304 not modified. This is kind of comes back to the cacheability aspect of REST. If you're going to do a 304 not modified, you have to have one of these headers present on your response: cache control, content location, the E tag, the date, the expires, or the vary. E tag, cache control, and expires are probably the most common. We're saying, you know, cache control wise, it has a max age of a week. So you're going to get a 304 not modified for the next week. So you don't really need to keep making this request. If we send back an E tag, then all I'm going to do is compare the E tag to what I have on the server. If they match, I will send back a 304 as well and just say, nothing's changed. You're good to just unravel this data and keep going. Or I might tell you, if you make a request and say, hey, 304 not modified, but this expires in 2 weeks. So you're going to want to check back in 2 weeks, but until then, you're A-OK. A 307 temporary redirect. This is just if you what's like a domain lapses or something, you just kind of want to point traffic into an maybe a canary server or something like that. Really, you're just telling the server real quick, you're just gonna go over here, but it's not permanent, so don't remember this because pretty soon we'll be directing traffic back to our main path. Whereas if you have a permanent redirect, it kind of goes back to that 301, we're moved permanently. And we just want to keep the original canonical links available for SEO reasons, but we want to tell you that the content that you're looking for has moved and you can find it in this place that we've stuffed in the location header. So we all know 400 bad requests. So 401 unauthorized. You might say you are who you are, and that's cool, but you may not be allowed to do whatever it is you're trying to do. And if that's the case, you get a 401. It says you're not allowed to do that. 403 forbidden kind of comes back to it as well. You might be authorized as an admin, but you may not have a particular permission. Like let's say you can view users and you can create users, but you can't delete users. For that, I would throw a 403 and just say you're forbidden from doing that one specific action, whereas you are so authorized to view and create users, which is why a 401 is not really appropriate here. 409 conflict. This is a good one for like, if let's say you have 2 put requests or 2 patch requests at the exact same time, the server is going to say, I don't really know what to do with this because they're both updating the same resource at the exact same time. So I'm going to throw a 409 and let the client try and figure out which one needs to be the right request and which one can cease trying to make their request. 410 gone. If a resource is moved from the server, let's say after you delete a resource and then you try and make a subsequent request to get that resource again, it's gone from the server. So this is where 410 is very appropriate to use. 413 payload too large. Think about like you're trying to upload a 5 million row CSV. Most servers are going to tell you that's way too big. You need to trim it down a little bit. It may be a time-based restriction. Like let's say you have 5 minutes from start to finish to execute the request, and 5 million rows is too long. So if that's the case, then you should probably pass some sort of retry header back and say, try again after 5 minutes, or something more descriptive. So that way they know what they need to fix about their request. 418 on Teapot, it has 0 applicable meaning. However, it's just really funny and I appreciate it. Once upon a time, someone made an HTTP request to a tea machine to make coffee, and they thought it'd be funny to respond with, I'm a teapot. 429, too many requests. This is one we've all probably seen with API throttling. If you just make too many requests within X amount of seconds, usually like 60 requests in 1 second is deemed by a lot of services to be the threshold of too much. They'll throw a 429 and say, slow down here for a minute, just calm down, and try not to make too many requests. The newest status code that exists is 451 unavailable for legal reasons. Excuse me. It was created for the Arab Spring back in the 2010s when certain countries were cutting internet and they couldn't serve content through the usual ways. So they came up with this. It references Fahrenheit 451, the book about book burning, which is why they use that specific code for censorship. 503 service unavailable. If you take your server down to do some maintenance or it needs to come offline for a little bit, you should respond with a 503 so that way they know that the service is unavailable with the expectation that the service will become available in the near future. 505 HTTP version not supported. As we move to HTTP 3, and I think there's already talk of HTTP 4, you're going to see HTTP 1.1 start getting deprecated and HTTP 2 kind of getting pushed to the side. So browsers or servers are going to start kind of caring about which version of HTTP you're using. And we're going to start seeing this code pop up more and more and more down the road. Okay. So the headers, the biggest piece of information exchange throughout this entire process. There's 4 different types of headers. There's general headers. There's headers that need to go in the request. There's headers that need to go in the response, and then there's entity-based headers. So accept and content type, these are ones that go to the request and response headers. When you make a request, you want to tell the server what content type you want to accept, whether you want application JSON, whether you want a particular flavor of JSON. GitHub has their own flavor of JSON. Microsoft has it as well. A lot of these super big vendors now kind of have manipulated JSON to their own liking. So that's why you see the VND dot organization. That's what that stands for. You may accept application XML. You may just want text plain or CSV. You can also pass a comma separated list of these. You might say, I prefer application JSON. I will accept application XML. I will begrudgingly accept text CSV in that order or with a wait option. When that, and the server may actually have to do legitimate content negotiation where it says, you know, you want JSON first, XML second, CSV third, but this data is best as a CSV. So I'm going to opt to send the content type back as a CSV. But so when the request makes that, the server should respond with what content type is being sent back, so the client knows how to deal with it. This is one of those ones where we've all settled on application JSON as our main form of data type. So you don't really see content negotiation all that much anymore. But it is still a thing that you may have to handle, especially if you're supporting Android, iOS, web, and other forms of IoT devices. I think Android still uses a lot of XML in their configuration type stuff, so they may still like XML. So you have to potentially be ready to deal with that. You might have like an authorization header, passing something like the bearer token or a basic username password that would be base64 encoded or MD5, something like that. But this tells the server what you can and can't do or who you are and things like that. There's going to be cache controls, both on the request and on the response, because the request may say, hey, I want this cache for, I want to be able to cache this for X amount of time. And the server might say, no, you can't cache this, or fine, you can cache it for X amount of time. Generally, the only ones you really see are max age and no cache. The other ones are kind of on the fringes of HTTP, but they are there to kind of keep in the back of your head. The location header, this is one I've referenced a lot. After you make a post request, you created a resource on the server. I want to tell the client, hey, this is where you can go see that data, make a request to that data. So I'm going to tell you exactly where to go to get that data. So the location header or the content location header, they're both interchangeable. And so this is what's being accomplished with that. You could also send the data back with the response, or you can do a location header and save yourself database queries on the response. E-tag, age, last modified. The E-tag again is a hash representation of the data payload. You might just want to say how old is this resource. And then you might also want to pass like, when was it last modified? So that way we can kind of do some stricter caching on our client side to know whether we need to re-up the request after X amount of days or just kind of keep it as it is. So some entity-based ones here. We have content length. It's going to be represented as an 8-bit bytes string of how big the content is. So this might be one where like we have a max content length of 1,000. Anything longer than that, we'll send back that 206 partial and let you re-up the request to get the last bit of the data and finish out the request that way. If your application supports multiple languages, you can pass back a content language where you do some translation underneath the hood of your application. And so you might say like passing back English or Spanish. You might say I prefer English, but I'll accept Spanish, or I'll accept Spanish, but I can handle right? I'm okay with getting English back if you have like a Spanish app and they may not have all the translations done in Spanish. So you might have to send back some content in English. That's what the content language is doing. The expires header is also saying this request is good through this period. After that, you're going to have to make a subsequent request because we can't after this period, data may be changing. The CORS headers, access control, allow origin, allow credentials, expose headers, max age, methods, and allow headers. These are all things that we talked about with CORS, but these are the 6 that you're going to see. Max age refers to how long you have to make that CORS request after the options request finalizes. The allow headers, which headers need to be on the next request. You allow methods, what methods you're allowed to make requests on, get, post, options, for example, where you're allowed to make the request from, the allow origins, and if you need to allow credentials or anything like that. So the last little bit is API contracts and tooling. Things like Open API, JSON schema, tooling, resources. We're really only going to scratch the surface. Open API itself can be its own talk. JSON schema is getting wildly popular within the API community now that Open API 3.1 supports JSON API. So keep an eye out on these kinds of things. They're definitely getting a lot more popular and a lot more robust, and some really great tooling around these. What is an API contract? Just like what it sounds like, if I have a server that is providing content, the contract basically says, I promise to fulfill these requests with these pieces of data, these attributes, and these responses every single time you make the request. I promise to handle these error codes, things like that. The client agrees to abide by those and make the requests in a way that my server expects them to. That is their end of the contract. And by both fulfilling both sides of the contract, we have a good flow, good API flow from client to server and back. Open API kind of is how we build our API contracts. It's I like to say it's the artist formerly known as Swagger. It is a description language that allows for things like not only API contracts, but documentation generation, testing, SDK generation, and more. The resulting file creates that contract that I was just talking about, that both the server and the client, or 2 servers, whether you have, if you have an AWS process talking to your server in the background, they can both reliably consume. One thing I like to point out is that Swagger, the way that we know Swagger, the API documentation is dead, and it's all Open API at this point. I made this tweet last year, funny enough, 4 days ago last year, and it caused a stir online because some people really are holding on to that whole Swagger namespace. But for all intents and purposes, going forward, everything that you know about Swagger in terms of the colorful API documentation is now Open API. Swagger still has a tool set under Smart Bear name, but the actual documentation is Open API, and we want to really work hard on calling it Open API so that way we can really kill off Swagger. Just to give you kind of like a quick mind meld of what Open API can do, we can do some functional security, load compliance testing on it. You can do some virtualization, some documentation. You can generate client libraries. It allows you to design your API first, which is where that whole design first API concept comes from. And what it ends up looking like is you can either do it as a YAML file, or you can do it as a JSON object. I don't know if that GitHub link should still be fine to check out. It probably just needs to be updated a little bit. Open API 3.0.3 is old. But as you can tell, like right here, we have metadata about our server. So this is a National Parks API. I'm a huge National Parks fan. I'm telling you a little bit about what the API can do. It supports get, post, put, and delete operations around data about the American National Park System and a way to contact me, things like that. But the meat of the Open API is this right here, which is the paths object. And what we're doing is we're describing what a get operation on API/National Parks looks like. And we're going to go ahead and describe what a 200 response is going to look like, all the way down to what the content type, application JSON. If we had application XML, we would support that here as well as what kind of properties we can expect back on for our object. So right here we have get parks, and you can see down here in the get parks example where we tell you, like, you can expect an ID. It's going to be an integer. A park EU ID is going to be a string. The name is a string. The year established is going to be an integer, and the state that the park belongs to is going to be a string as well. All of this can be bundled up, and from this we can write tests, functional tests, as well as unit tests around our API. There's tooling now that kind of looks at your open API definition as well as your actual API endpoints and compares them. And we'll show you a diff about where you differed from in your development. So that way you can rectify your code changes with your API contracts. So that way you don't ever break that contract. It's a tool called Optic, which is a really awesome tool to check out. But so this is what OpenAPI kind of gives you. And it allows you to kind of sit up front and build your API without ever writing a single line of code. So when you do start writing code, instead of having to constantly iterate over building your API, you can think about it this way first, think through all the different scenarios, and save time in the long run actually coding your implementation. So JSON schema is another piece of the puzzle. It allows you to annotate and validate JSON documents. And what it looks like, so we might have an object coming back that has properties on it, like a post office box, an extended address, street address, locality, region, postal code, country name. This is obviously written by someone who lives in England because that's where the maintainer lives. But what we're basically saying is these properties should expect to be on the object, and we can validate them with the type that we've declared here. We've also said that in the response, locality, region, and country name are required to be there. If we have post office box, we need to have street address. If we have extended address, we also need to have street address in our JSON object. And that's what JSON schema allows us to validate against. We say everything should be there with certain rules. Now go validate our object and make sure it's there. So OpenAPI versus JSON schema, they used to kind of coexist and kind of side-eye each other. But a lot of work, especially Phil did a lot of work in OpenAPI 3.1 to kind of rectify a few differences between JSON schema and OpenAPI. So now they play really nicely together. And now they create an incredibly powerful tool set if you're looking to get into design first APIs. And if you are, you're more than welcome to shoot me a message on Twitter, and I'm more than happy to nerd out about those kinds of things. Some tooling that I like, Postman is a great HTTP testing tool. Same thing with PAW. PAW is Mac only. So if you're not on a Mac, Postman is the way to go. HTTP Pi is a great CLI tool, as well as Insomnia and Postwoman. I know Postwoman is open source. Insomnia might be open source as well, in case you are a big OSS fan. Those are two options there. Stoplight Studio is great for OpenAPI documentation. Provides a really nice intuitive GUI to build that API contract. Spectral, which is built into Stoplight Studio, is a linter to make sure you're following the rules of OpenAPI. Dread.io is a JavaScript CLI testing mechanism for APIs. So if you want to have functional API tests, that's one way to do it. And then JQ is a way to kind of map, filter, and slice your JSON on the CLI as well. And last but not least is some resources. So there's this book that this guy wrote once upon a time. It's called APIs You Won't Hate. He somehow turned it into a little empire that I currently help out with. There's a book, a blog, a podcast. We should probably podcast soon. The API Evangelist is another really good blog. Ken talks a little bit higher level, like API governance and things like that, but he has some really great tidbits, especially if you're in a larger organization where like breaking changes and stuff like that have wide-ranging consequences. His blog is gonna be great for that kind of stuff. Nordic APIs is another really good blog where they get really deep into OpenAPI and REST concepts. They also have a few conferences over in Norway, if you're ever over that way. And then it's just some people to follow. Phil, I mean, he talks about trees a lot, but he also does talk a lot about APIs. Ben Hutton is JSON schema maintainer. He's a really good guy to follow. Ken Lane runs Open API Evangelist. Daryl Miller is leading the Open API implementation right now. So if you want to really get into the mind of like how they're building Open API, he's a great follow. Mike Amundsen is a great thought leader for APIs. Same thing with Arnaud Laura, who tweets under Open API Handyman. And then Mike Ralphson under Permitted Soft is another technical steering committee Open API member. If you're wanting to dive deeper into this world, these are some of the people I would highly recommend following. And with that, thank you. I appreciate it. This is where you can contact me if you have any questions. And at some point, I promise we will talk about why we build APIs we don't hate anymore.
Awesome. Thank you, Matt. It's good to have you back.
Yeah, it's good to be back.
Great API talk. I definitely have some questions. I guess I'll get us kicked off. If anybody watching on YouTube or on Zoom, let us know. Just hit that Q&A button if you're on Zoom, or drop Matt a question on YouTube, and then we will pass it along to him. So while I ask Matt questions, start thinking of your own. So Matt, can I volunteer to have you come back and speak again? Because something I would be really interested in hearing a talk on is HTTP 3 and like its impact on APIs. Because like looking at Google and Wikipedia, it's like how is it impacted? Like I know it's like a blend of TCP and UDP, and headers work differently in UDP. Like I think there's like a lot of really interesting information, and since you're really into APIs, I think that would be a great talk. How about you?
I would need to do some research, but I think that would be really interesting. Like I'm Googling HTTP 3 now just to kind of understand it a little bit more. I wasn't actually, I didn't know that the headers operate a little bit differently. So let me do some research on that one. But I'm definitely open to at least presenting my findings in some way, shape, or form.
Yeah. I mean, that I think just getting us thinking about it, right? And and I, on Wikipedia, it says like it's supported by most browsers now for like a year. So you might actually be able to find some way to test kind of like some requests and responses and see like what's possible.
That'd be super cool. I'll have to check that out. I'll let you know when I find a little bit of time here in a couple of weeks.
Great. And then so bearer tokens, where does that fall in to? I don't think you mentioned them specifically, but in authorization, like how bad are they? Can you touch on bearer tokens a bit?
If they're bad, I don't totally know about that. I know that's how we do it through our applications, and that's kind of just the way I've defaulted, since that's the OAuth way of doing things. It's just OAuth itself is a pain, and that can be its own talk, really. I prefer that way, because with OAuth and stuff like that, I can tell not only who you are, but what you're allowed to do through the code that I write. So that's generally why I opt for bearer tokens. But they've also been kind of bastardized a little bit. Like JWATs can kind of be shoved into the bearer token aspect of it now too. They kind of have opened up instead of it just being an OAuth thing to now being kind of a catch-all for authentication and authorization, which is probably what you're getting at with them being not the greatest thing anymore. But I have no idea what's a better option. JWATs are okay. They're fine. They require a little bit more knowledge, especially around the encryption layer. which is why I kind of just, if I have to roll my own, I just grab the league's OAuth 2 server and kind of let it handle it for me. Because authentication is one of those things where it's like, if you get it wrong, like you're asking for trouble. And so that's probably the part that I know the least of in terms of APIs, because I prefer to just let the people smarter than me handle it, and I will just implement what they have told me to. And maybe I'm just too trusting of an individual. But I will screw up authentication if I have to roll my own. I know I will. And so that's why I just stick with what I know. And that's why I prefer OAuth over everything else. It just works.
Yeah.
And so
hard to go wrong. So yeah, I was maybe it's a little bit of a leading question. So it sounds like, it can be good in some cases depending on implementation. I have run across APIs in the past where the bearer token does not change.
Mm-hmm.
So, and I'm like, maybe that's not the best idea.
Yeah, like I at least put some sort of like time stamp or a time declaration or something, like invalidated after 20, however long you want to invalidate it for. Like if it's just always going to be there, that feels like a security hole.
If you're not rotating it automatically, then it's just like you're gonna forget about it, and
Yeah, and then you're gonna end up on have I been pwned, and nobody wants to end up on have I been pwned.
Yep. Great. Any other questions for Matt? Maybe from the panelists. We've got a Sean from Vancouver joining us, and I'm going to bring him up here to speak when he's ready to tell us about Vancouver PHP.
Nice.
We're slowly growing the Merge PHP user groups here. And Sean, your video's on. You're there. Good.
Hey there.
Welcome. So I just want to ask Sean a few questions here, if you don't mind, Matt. So can you tell us a little bit about Vancouver, like how long the group's been around, and are you doing your own YouTube thing since the pandemic?
Yeah, absolutely. So I'll start off. Matt, thank you for the talk. Basically preaching to me and I got the choir. Really loved it. I definitely have had the frustration of working with an API that I've just pulled my hair out and been like, why am I even here if you're not going to follow the standard? So aside from that, the Vancouver PHP group, I want to say I joined maybe 4 or 5 years ago. It's been a while. And we used to have in-person talks every single month in Vancouver, get the beer, get the pizza, have the group, and have 1 or 2 speakers. We went back and forth on whether we should move to YouTube or offer YouTube as an option. For the longest time, we decided not to because we wanted the people to come to our location as opposed to being introverts and hiding at their home or their desk and whatnot. So we wanted to see the people in person, so we encouraged that. Unfortunately, the pandemic changed everything and everybody had to go remote, and we struggled. You'll notice on our YouTube channel there, I want to say there might be only 2 or 3 videos, and it's something where we struggled to really make this a consistent thing with the pandemic. My co-organizer, James Doyle, and I, and we are overdue to, I don't know, put something together or actually put on another YouTube live. So by being a part of Merge PHP, you're kind of giving me the kick in the butt to actually follow through and make something happen. So I think in the next month, we will figure out whether we're going to do in person and record it on YouTube or do it on YouTube and just continue to be kind of staying away from each other. So yeah, and really it's like your standard user group, all about PHP, but we do allow some extra talks in there that help supplement the knowledge of developers. So I think while an API talk is not necessarily PHP, but it helps supplement the knowledge to level up all of the PHP developers to become fantastic API developers. So we open it around the same kind of parameters. That's my spiel.
Awesome. Awesome. So I think it sounds like you're open to PHP adjacent talks.
Yeah, we have had a few Vue.js talks. Thwool was one before Thwool or before Laravel did their Thwool thing. There was Thwool PHP, and we did talks about that and how to utilize it. And we do try to stay with PHP because we want to level up all of the developers who do enjoy working in PHP.
Awesome. Well, we'd love to have you join the merge, the merge PHP task force, as we called it originally there, a play on Matt's name, since he was one of the first speakers, and we were trying to like think of a good name for the group. But yeah, I think I told you on our Zoom earlier that, you know, Ben was instrumental in kind of getting the core groups there together, and Tim is here now from Seattle. You know, I think next month we're going to start a little bit different. We didn't quite make it with, you know, getting organized for this month, but we're going to do a slightly different intro next month. I think that a little bit streamlined intro will be better for everybody. But yeah, we'd love to have you. We'll get you added to the Slack group, and then there's like a spreadsheet in there, and we can talk some more about that. But definitely send me your email on Twitter that you want to, you know, to use for, you know, the meetup stuff, and we can get you added to things.
Fantastic. I'll drop you a message immediately.
Awesome. Bobby, Chris, what do you got?
No questions for me.
Ben, I know you got some questions for Matt.
I have a question.
No questions. He answered everything. What's your least favorite HTTP status code?
Oh, your
I
Mike's.
don't know.
Oh, there we go.
Jeez. I mean, I wish there was something better than just 400 bad requests. Like that feels like a catch-all of a lot of different things. I really kind of wish there's like you could take the 470s, 480s, and 490s and kind of expand upon those and be like, you know, password not strong, 471 password not strong enough, 472 password invalid, 473 you know, something like things like that, versus just turning it on to a catch-all 400 bad requests, which kind of just feels like 200 okay is kind of a catch-all for all good operations. So I feel like 400 bad requests is kind of just there. Yeah, like I would love to see the 400s expanded to be a lot more descriptive and a lot more versatile.
Somewhat related. What's the worst API or the worst implementation of REST that you've ever worked on?
Oh,
That you didn't write.
that's fair.
Or
Be
that
sure
you
to
wrote?
throw everyone under the bus.
Well, so there's this one really large furniture retailer up in Boston. Their API is just absolute no.
Restoration Hardware.
I thought that was Tennessee. I don't know. Maybe it is.
Oh, they have one in Boston. I don't know if they're based there.
Actually, they have one here, and there's a restaurant on the roof, and it's really weird. And like that's where like all the hockey players and their wives go. So like I know I can never afford that restaurant. I think like the worst is probably like PayPal and eBay. Were two of the ones I remember early on in my career just being absolute garbage, both documentation wise, abusing status codes, and not following through with the proposed. I mean, this is before API contracts were really ever a thing, but you'd read their documentation, you would just get back something completely opposite of what they say you should get back. Those two were pretty big. Big Commerce was pretty bad at the beginning, but they've actually gotten a lot better. Actually, at my last job, one of the last things I did was implement around Big Commerce, and their APIs have definitely gotten a lot better. So whatever they did, they definitely deserve some high fives and some congratulations on the work that they put in, because I can tell.
Okay, my
Yeah,
last one. Where
fair.
is the Baby Yoda picture? And why is it not behind you? I can't see it, Matt.
Oh, that's awesome. Very nice.
Best $25 I've ever spent. I'll have to tell you the funny story about it one day, Ben, when we're drinking. No, I can't get it up there.
We can cover the history of the Baby Yoda on the next PHP Town Hall. A teaser.
Cool. No, let's do it.
I've got a question, if I may.
Sure.
So this is to give them background around it. So my expertise comes more like being more of a tech lead manager at companies and trying to level up the developers within the company, and of course in our PHP meetups. And I see a lot of ugliness, like a lot of what you talked about, a GET request, and then the method name is get foobar, and it just drives me nuts. Those little things. Do you have any insight on where this comes from? Like, where do these little intricate mistakes that we see over and over, where do they come from? Do you have, not that I'm saying you have the answer, but do you have any insight or thoughts where is this starting? And so we can go nip it in the bud.
I mean, I don't want to cast aspersions on older developers, but I don't know at what point you entered the talk in the room and all that. REST was serialized in I think 2000. So before that, it was all kind of like the Wild West of passing information over the wire. A lot of RPC, remote procedural calls, where you're passing get users, and the browser was reading get users, taking it and shoving it in magically into the code to make that request, versus mapping a URI to a controller that we're more familiar with now. So it's like I said, I don't want to cast aspersions on older developers, but it's definitely that legacy of the RPC, the kind of old school way of doing things before REST really got popular. You definitely hopefully don't see it, like, unless you're working like a super duper legacy system. It definitely is not as prevalent now, like if you're going to start something new, but in applications that are probably 10 years old, I think is probably around the time where like REST kind of took off. It went from being like just a fledgling white paper by one person to kind of gaining acceptance. So even though he wrote it in 2000, it still took a little bit of time to get that information out, for people to digest it, for people to understand it, for people to put it in practice. So I think it was around 2010 is when REST really kind of took off from what I've kind of understood. And so, you had that 10-year period there where REST was defined to accepted, but it's still the Wild West. And so that's kind of where I think it all kind of stems from. I think even in code schools that like get the bad rep of, cranking out developers, they're like, I've seen some of their programs, like they're at least trying to do REST-ish things. So you won't see like a code school cranking people out with like get dash users dash for dash, something like that. So I think it's just it's legacy code that has just persisted because it makes money, and people tend to be afraid to change that kind of stuff if it is a moneymaker.
That makes sense. I did have 2 code review today where I had to call out that particular get in the method name, and it's repeated in the get request. And their excuse was, "Oh, I saw it on a old piece of code." And yeah,
Yep.
you're exactly right.
That's like the bane of a lot of like senior level team leads. It's like, I saw it somewhere else. It's like, it's cool. I saw someone texting and driving. Doesn't mean you should do it. Like, it's a terrible idea.
Tim, did you have a question? I think
So, Matt, when you came up with the title for this talk, were you listening to the Jackson 5?
Actually, yes. Because we so absolutely unrelated. My mom was in town. Well, I mean, I listen to Jackson 5 anyways, but like it's been in my head for the last couple of days because so we have the National Museum of African American Music in here in Nashville, and it just opened. And so we went to that museum. And like I've just been on a soul R&B blues kick for like the last 4 days. And so yeah. But
So
it's also
there's
like,
one of those older developers. I haven't thought about Jackson 5 in years.
they feature pretty prominently in the museum. I mean, as they should. They were seminal
Cool.
to music, but I like actually I the title came from Ken Lane. He had a blog post that had this phrase, the ABCs and 1, 2, 3s of rest. And I was like, that is a great title. I'm gonna steal it. And I did. And here I am.
I can't remember the website where it listed all the different status codes, but I found a new one. If you go to http statusdogs.com, I don't know if you guys know about that. They got like different dogs for the most commonly used status codes, and it's pretty great.
There's also http.cat if you're a cat person.
Yeah, the cat one I like. I use that in my my restful talk that I give.
I just like
I
the
used to give.
100, the cat
Oh,
like hovering.
I like that one. That's a pretty awesome domain name.
Cool. Enhance your calm. It's about that time.
All right. Well, let me stop the recording here,
Get that comment in there.
but we can hang out and for a bit.
When you were asked what your favorite response code was, I was waiting to hear 418. I'm a teapot.
That's our
Oh,
scrum team
That's
name,
like that's
actually.
the standard answer for that question. What?
That's our scrum team name.
That's awesome.
They tried to remove it from Node.js a couple years ago, and I remember like people were rightfully like flipping out about it. I'd like to see 420 enhance your calm become a real one. That'd be fun.
That'd be great.
That would,
I mean, like legitimately though, I'd like to see like the 400s expanded just to cover more use cases besides 400, but I have
It's,
no idea how to like try and do that.
This Elon Musk takeover bid works somehow. They should definitely just return 420s for a day
yeah.
from Twitter.com.
That would be
Jesus, take the
good.
wheel.
a good idea.
One of my favorite APIs that I worked with back in the day, everything was a 200 response back, but I would get a string that had the error code, but it wasn't like 404 with the error code. It was their own error code, and so it would be like 200 response error code 1 in the JSON, and then I would have to look at their documentation. Say, okay, what is a 1? Oh, 1 is a field missing or something. 2 was the something else, and in our code we had to build all this garbage like condition to be like, okay, if it's a 1, do this. If it's a 2, do this. If it's a 3, it's a path. If it's 4, it's a redirect. It was, oh my god, it was disgusting to say the least.
So it's actually funny, like, so I was looking on http.cats, and I mean, I'll preface this with, I actually really like Laravel. I enjoy developing in Laravel. But if you use Sanctum, their token, their API token, if you get it wrong, it returns a 419, which is not a real response code. And like every time I get stuck on that, I Google and I'm like, why can't I find 419 in any of the like HTTP cat, HTTP status dogs? Then I just realized there's 498 is a legitimate status code, token expired, invalid. And I'm like, why are like that's what you need to be responding with.
The Sanctum
Sure.
pull requests.
The
Yeah,
Sanctum, like the API token thingy, my bobber.
Yeah.
Like it's a cool library and I like it. And it does a lot for you, like to, like I said, alleviate authentication that I don't want to deal with. But you get that 419 and you're like, okay, you know, like if it's been a minute since you've done Sanctum, you're like, okay, well, what's a 419? And then you're like, there is no defined 419. And then you gotta, you know, it's Laravel hijack that code because it's available. So I understand it, but it's just annoying, especially now that I know that 498 is an actual token expired or invalid, which could work in that case.
Interesting. So the doc site has 419. I actually didn't know this. And I just did 419 status code Google search, and there's blog posts about it. But I wonder if it's Laravel that kind of made this a reality.
Yeah. I mean, if you like HTTP dogs and HTTP cats are cool, but like the actual source that I go to for legitimate API stuff is like Mozilla, and they're not going to have 419 defined at all.
I just found in Wikipedia there's a list of HTTP status codes 419 used by the Laravel framework when a CSRF token is missing or expired. So you're right, it's them. And there's a bunch of other ones in here too, like the Spring framework does the 420, Twitter is 420, enhance your calm. There's a whole bunch of them.
I think Cloudflare has a lot too. I think they have like a 529 or something like that is a big one.
520, 521, 2, 3, 4, 5, 6, 7, 30. And AWS.
Yeah, that page with all the unofficial codes. There's a bunch in there. I'll drop the link in the YouTubes.
Yeah.
There.
That's cool. I had no idea that they were
that's like
unofficial.
That's my like only real complaint for Laravel is like there's an act like now that I know there's a legitimate HTTP code, like definitely you know, use that instead of your made up one.
Yeah, I agree. That
So-
just makes them more inconsistent.
I mean, is the IANA ever going to like, you know, add new ones, or is it just going to be kind of like the unused ones is just like the wild west, and you know?
I know you can add new ones. I mean, 451 legal.
That was
What was that?
that was the newest one.
I think that should be the newest one. Trying to figure out. Let's see. It was proposed in 2013 by Tim Bray. It was approved by the IETF on December 18th, 2015. Published RFC 7725, February 2016. So I'd imagine. I don't think there's been a code come out since then. So I mean, if you know Tim Bray, he was like one of the distinguished programmers at Amazon, I think. So he knows how to navigate that whole process. Where like, you know, like Taylor, myself, I have no idea how to navigate the IETF, the IANA process, any of that. Like, I have no idea. So you gotta like find a heavyweight to get in there and kind of champion these things. So it can definitely be done. It's a process like everything else.
These big like nonprofit or like, you know, government entity kind of stuff is like it seems like you need a large organization just to deal with like all the red tape and kind of the different hoops, you know, and people that you need to know kind of thing. scenario to get that stuff added. So, Laravel's a big project, but they don't have people just sitting around responsible for emailing, this
Yeah.
IA.
Like Amazon does. They
NA,
have the money,
yeah.
Laravel's still like a 5-6 person operation. So yeah, it is what it is. But it's that kind of stuff like with REST too, because people are like, oh, 419. I'm like, that's not a real code. So then I just go get on my bike and forget about it.
I mean, Cloudflare and AWS should definitely look, Cloudflare's got 10 of them that they're using. A bunch of different ones, all in the 500s.
Well, I mean, so 251 was first proposed in 2008 by someone named Chris Applegate, again in 2012 by Terrence Eden, and then it says formally proposed in 2013 by Tim Bray. But it didn't become officially an RFC until 2016. So that's 3 years of a heavyweight like Tim Bray pushing it through. And I mean, I don't want to, I'm sure Cloudflare has heavyweights as well, but yeah, I mean, there's it's a standards body. You got to play the game. You got to play the office politics game with them too. So it might just be easier to hijack empty codes. Do what you got to do. So.
Yep. Call it a day.
Call it a day. I got to jump though.
Well, thanks so much, Matt, for the talk.
Yeah. Thank you guys. I appreciate it.
Thanks
Thanks,
again, man.
dude.
Appreciate it a lot.
Yep. See you guys later.
Take care, man.
So any questions for us, Sean, before we go?